Hello student, welcome to Study Doubt. This question is from Physics, chapter Magnetism. Here it is given that a charged particle, after being accelerated through a potential difference V, enters in a uniform magnetic field and moves in a circle of radius r. If V is double, then what is the impact on the radius of the circle? So let's understand this question with a figure. As you see in this figure, we have a magnetic field. This is the magnetic field. And the meaning of this cross is the magnetic field is away from us. So here in this system, we have a charged particle. This charged particle is about to enter in this magnetic field, and because of the influence of the magnetic field, a force is developed, and this force makes this charged body to rotate in a circular path. So we have to find what is the impact of the change in the radius when the potential difference is doubled. It means that if initially the potential difference was V, this is the initial potential difference, and V dash is the final potential difference. Now V dash becomes the 2 times of the V. So what is the impact on its radius? So we have to find it. So let's understand this question. Here we are applying certain work. And we know that V is equal to, means potential difference is equal to work upon charge. So based on this relation, can we find work is equal to V into Q? And this work is actually a kinetic energy. This work will form a kinetic energy. So from here we can say that V into Q is equal to half into m into v square. So this is the velocity and this is the potential difference. So from here v square, I write the velocity, so it's easy to understand. Velocity square is equal to 2 into potential difference into charge upon m. So velocity is equal to how much? It's equal to root of 2vq by m. We found the velocity, but the question is why we are finding the velocity in this question. Actually we have to find the radius. So why we have to find the velocity? Because to find the radius we need a velocity formula. Why? Because when this charge, let's take this charge is reaching to this point, okay, that time it has certain velocity v. So magnetic field is where? Downward direction. So there will be a formation of a force here. And this force is actually the centripetal force. It's mv square by r, because centripetal force is responsible for the circular motion. And this centripetal force is a magnetic force. So we know that when the charged body is present, velocity is present, and the magnetic field is present, F is equal to QVB. So based on that, we can say that m into v square by r is equal to charge into velocity into b. So this gets cancelled. So now r is equal to mv by qb. So this is the radius relation. In that, what is important to find? This is the velocity is important to find, because charge is constant, magnetic field is constant, mass of the charged body is also constant, only the velocity is changing. Now you see this velocity is actually, what you notice, it's directly proportional to the square root of the potential difference. So initially the velocity was v. Now if the potential difference becomes double, so what is the new velocity? Let's make it as v1. So it's directly proportional to root 2v. Why? Because potential difference in the final is 2 times of the initial potential. So radius is proportional to the velocity. From this relation we can say. So based on that, can we write r by r1 is equal to v by v1. Understand, these are velocities. So let's substitute the value. R by R1 is equal to, velocity in this case is equal to root of potential V by root of 2 times of the potential. So now these two potential will get cancelled. So R by R1 is equal to 1 by root 2. So from there, R1 is root 2 of R. So the new radius will be root 2 times of the previous radius. So according to this, option B is matching correct here. So this is the answer of this question.